Hello guys, welcome to the course of TCP/IP. Today we are going to discuss about the TCP connection. Before this video, what we have discussed about the TCP protocol, the header format and transport layer function, and some kind of port numbers structure. So now it's time to discuss about the TCP connection, guys. So let's start the background of TCP connection. Now, as we know, guys, the TCP is connection oriented. Now, what do you mean by connection oriented? A connection oriented transport protocol that establishes the virtual path between the source and destination. So let's say if I have a source and if I have a destination, so before transferring any data, what we have to do, we have to establish a connection to transfer a data. And that's why that is called as what connection oriented. On that particular connection, all the segments belonging to the message are then sent over the virtual path. So whatever the path we have created, on this particular path, the segments are going to be sent. Using the single virtual pathway for the entire message facility, the acknowledgement process as well as retransmission of damage or loss frame is available. So there is acknowledgement facilities available because it is more connection oriented. And if any packets, if any segments are damaged or let's say lost, that time the retransmission can also be possible because we have a track and we have the path. The TCP operate at the higher level. The TCP uses the services IP to deliver individual segments to the receiver, but it controls the connection itself. So TCP is connection oriented and IP is connection less. So only because of the fast in nature, the TCP is going to be used to take a help of the IP protocol. But the TCP itself is what the connection oriented protocol. And on the internet, it is going to be preferable. That's why it is going to be use of the IP protocol. And if the segment is lost or corrupted, it is going to be retransmitted. And if the segment arrives out of order, the TCP holds it until the missing segments are out. So what about the connection oriented, guys? We have discussed in the previous lectures, also chapter 1, that this order, let's say if I have 1, 2, and 3, this is what the order. In this order, only the every segments are going to be flow. Every segments are going to be travels. And if someone missing at, let's say if at the end 1, 2, and 3 is, if 2 is missing, it is wait until it is received, and there's exact the same sequence it is going to be received by the receiver. This is what the beauty, where the data dependency or segment dependency is more, as like in the connection less, there is no dependency, but here dependency is more. In this TCP, the connection oriented transmission required 3 phases, like a telephone dial-up. The 3 phases are what? Connection establishment, data transfer, and connection termination. So we have to discuss these 3 phases in this particular video lecture. So I have give you the brief intro about the, what we can say, this connection oriented services. Now let's take the go to the second slide and see the connection oriented in that connection establishment. In this connection establishment, TCP transmit data in full duplex mode. And what do you mean by full duplex mode? Sender can send, receiver can receive. Meanwhile, receiver can send and sender can again receive. This is what the full duplex. At the same time, this is what the bidirectional kind of thing. Now, before having the connection establishment, what we have to do? We have to do the prior to the connection, it must reserve the resources. Which type of resources? Like a memory, processor, and the buffer. For what? Because buffer is required to store the segments, processor is required to process that item, and again the memory is required to save that particular item. In there are more than one segments are available. So this type of resources are need to be taken to reserved, the provision to be made earlier to the data transfer, and that is what the connection establishment. Because whenever, let's take an example of any telephone connection, a dial-up connection, where we dial a number of any particular receiver, that time sender and receiver, in between them, the one dial-up connection has been established. So here we are reserving the resources, we are using that path, we are creating that path, we are creating virtual path. On that path only, no other can access, no other have any access of that particular path. So it is reserved in between the sender and receiver. And this reservation can also be happened with the, let's say, 3-way handshaking. And what happened with the 3-way handshaking? The connection establishment in TCP is called as a 3-way handshaking. When the clients want to make a connection with another application program, it called a server. Okay, using the TCP as the transport layer protocol, what happened with this three-way handshaking? Very first, the process start with the server. The server programs tells its TCP that it is ready to accept the connection. This request is called a passive open. Although the server TCP is ready to accept the connection from many machines in the world, it cannot make the connection itself. So server cannot make the connection itself. Like we are connecting from our PC to the Google. So we need to take an initiative to connect that particular Google server. Then the client program issues a request for the active open. Okay. Then client that wishes to connect to the open server, it tells the TCP to connect a particular server. So what happened with this particular 2 to 3 sentences? Consider here is a sender and here is a receiver. A receiver consider a Google server. This is what the Google server. So what happened with this? Very first, client is what the active open. Client is what the active open. Wanted to take a connection to the Google server, and server, that is what Google server, always passively open. Always passively open. He is always searching for any request. If the client want to take the services of the server, then it sends the request. Okay, as a request, then it is going to give a reply, and again the acknowledgement is going to be sent. And this is what the three-way handshake: request, response, request, acknowledgement, again then response. Okay, this is what the three-way handshake. Now, in this three handshaking, apart from this, what happened after having the connection established in this particular TCP phase? Here, the three-way handshaking is going to be happen. And in this three-way handshaking, the sequence number, the acknowledgement number, and the control flag is going to be used. And again, the window flag is going to be used. While this window flag, what happened? So let's take one by one. So the very first is what the connection establishment. If you see the diagram, here there is a client process and the client transport layer. Here there is a server process and the server transport layer. What happened with this? Client is what the active open, and the server is what the passive open, always 24/7. Any users like us want to connect the connection with the Google server. What happened? It need to advertise the information in the TCP header format. So this is what the TCP header format. Whatever the field what we have, out of that, whatever the required field we can send. So in this particular, first of all, what we have to set? We have to send a port number. Let's say I have a port number with A, my machine which having running one application with the port on the port number A. And here the port number, let's say 80, because 80 is what the port number of HTTP. Okay. So port number, my machine port number, my application port number, and to whom I want to connect, that is what I have to send. Apart from this, what we have to set? We have to send the sequence number. But we have to send the sequence number. Okay. This sequence number is what? The starting. The sequence number is what? The starting. And this is for what? The sync. I want to synchronize with you. That client is saying, I want to synchronize with you, because unless and until we have a synchronization, we cannot make any kind of communication. So I want to synchronize with you. Apart from this, what we can say, we can advertise our window size. Let's say WS, window size. And what the window size? I have a window size of, let's say, 12,000 byte. So this is what the maximum capacity I can hold. Apart from this window size, and what we have to specify, I have to again specify the maximum segment size. Let's say MSS. Although I have, let's say, 12,000 byte of what we can say the window size, but at the same time, my maximum segment size is what? Only, let's say, 1200. So what is going to be then? 12,000 divided by 1200. 10 maximum segments I can hold. The maximum carrying capacity is what? 1200. It is only for what? If any segments are more larger that time, because client and server, in between this, there are lots of networks are available. So at the time of the network reaching that segment, we have to specify that particular MSS also. So what happened in this summary over here? So here all the fields can be set, but the required fields we have set it. Okay. In this, the client send the first segment, then segment or the synchronization of the sequence number. Then client chose the random number, and this what sequence number is what the random number. It is not going to be start from with the 0. It is random number at the first sequence number and send this number to the server. Then sequence number is called as the initial sequence number. Then sync segment is controlled segment and carries no data. There is no any carries no data. However, it consumes the one sequence number. When the data transfer start, the ISN is incremented by 1. Okay, and this number is going to be selected randomly. If you not selected randomly, so everyone is going to be take the 0, so that will be create a problem. So it is going to be selected as a randomly. Okay, and the sync segments cannot carry data, but it consumes one sequence of number. So I hope it is okay with you. That is active open as a client to the passive open as a server. Client is sending the request to the server with all the provisions in the header TCP header format. What happened with this? What happened with this? The server can reply. Server can reply with what? The sync plus acknowledgement. Sync plus acknowledgement. Okay, and sync plus acknowledgement, how it is going to be done? Sync plus acknowledgement, where the sequence number is again server have selected the sequence number, let's say 5,000, 15,000. Acknowledgement number is what? 8,001, because sequence number initially sent by the server client is what? The 8,000. So acknowledgement to that 8,001. Then apart from this, what we have the receiver window size, that is 5,000. Acknowledgement and the sync flag is also set. So to this request, sync plus acknowledgement is sent by the server to the client. Here also server can advertise the maximum window size and the MSS also as per their availability of the data. And this can be achieved via whatever we have told earlier, and this is going to be achieved via this sync plus acknowledgement. After this sync plus acknowledgement, what has happened? The data transfer can be happened. What happened in the data transfer, guys? When two TCP in the two machines are connected in bidirectional, data transfer can take place. The client and the server can send the data and acknowledgement in both directions. That's why it is what the bidirectional. They are able to send the segment to each other simultaneously. In this example, here in this diagram, the connection established. The client send the 2,000 bytes of the data in two segments. So here 1 and here 2. Okay, so here 8,000 to 9,000, here 9,001 to the 10,000. That's why it is 2,000 bytes. The server send the 2,000 bytes in the one segment. The client send one more segment. Here it is sending in the one segment also. Okay, the first three segments carry both the data and acknowledgement, but the last segment carries only the acknowledgement because there is no more data to be sent. There is no more data to be sent. The data segment sent by the client have a push flag is set. The flag is set. Okay, so that the server TCP tries to deliver data to the server process as soon as they are received. The segment from the server, on the other hand, does not set the push flag. In most TCP implementation, they have set the option to set or not this set flag. And this data transfer can be happen with the piggybacking and the pure acknowledgement. This data transfer acknowledgement can be happen with the piggybacking and the pure acknowledgement. What happened? After the connection have been set up, the data and acknowledgement can be sent. If at a time the data and acknowledgement can be sent, that is called as what? The piggybacking. So wait for the data and then send the acknowledgement is what? The piggybacking. And the pure acknowledgement is what? Don't wait for the data. Suddenly, whatever the data we have received, send the acknowledgement. That is called as what? The pure acknowledgement. So this is what the data transfer. Now, after data transfer, what is going to happen, guys? The TCP termination, that connection termination. Any of the two parties involved in the exchanging data, either the server or client, can close the connection, although it is usually initiated by the client, because client have made the request and client done their task. So immediately the clients want to terminate the connection. The most implementation today now allows two options to connection termination. One is what the three-way handshaking, and another can be a four-way handshake with the half close option. Okay, but most preferably three-way handshaking is preferable. Three-way handshaking is preferable. What happened with this? In the common situation, the client TCP, after receiving a close command from the client process, send the first segment as a fin segment in which the fin flag is set. The fin flag is set with the fin segment, and fin is what? Finalize. The final, I want to terminate the connection. What happened with the reply? The fin segment can include the last chunks of data sent by the client, or it can be just a control segment. So in this particular frame, a TCP header frame, it can be only a fin flag, or it can be a data. But if if they have data, they can send. Otherwise, it is only a fin flag. It is only a control segment. It consumes only one segment number. It only consume one segment number. Then what happened after this doing? This what server will do? Server will the server TCP, that is server TCP, after receiving the fin segment, inform its process at the server side of the situation and send the second segment called as fin plus acknowledgement. So after sending the fin from the client side, the server have responded that fin flag and fin request, and it is responding fin plus acknowledgement from the server side, server TCP process side, okay, to confirm the receipt of fin segment from the client, and then same time to announce the closing of the connection in the other direction. So after receiving the fin flag from the client, server agreed on that. Server informed this process, TCP process, and send the fin plus acknowledgement, and it is agreed for the closing of connection. And this segment can also contain the last chunks of data from the server. If it does not carry data, no, it consumes only one sequence number. And this can be a last. There can be a data with us from the sender, because if server want to send, server can send the data. If it not, then only acknowledgement can be sent. The client TCP send the last segment. The client TCP send the last segment to confirm the receipt of fin segment from the TCP server. Okay, so this is what the last segment. Where this segment contained the acknowledgement number. Here we have acknowledgement flag as set, which is 1 plus of the sequence number received from in the fin flag. Let's say here acknowledgement is what? 1x plus 1 of the previous one. So here again the y plus 1 is available there, because whatever, let's say server have send the 1000 as the sequence number. So here what we have to send? We have to send the 1000 plus 1. Okay. This segment cannot carry data but consume no consume any sequence number, because this segment number is as a reply to this particular server. It is not consume any sequence number. Okay, as a reply. Then what happened with the termination? There can be a different cases. The cases can be like this. Half close. What do you mean by half close? In TCP protocol, one end can stop sending data while still receive data. It means what? In TCP, one end can stop sending data while still receiving data. It means what? This is called as a hop close termination, and free all the resources. What happened with the termination? We have to free all the resources, whatever the resources we have reserved at the time of connection establishment, they have to receive. Either server or the client can issue the half close request. Okay, whosoever want to make the connection termination can issue the half close request. It can occur when the server needs all the data before processing it can begin. Okay, so either client or either server can issue the command of the half close. That what happened? They no more to have the agreement over this particular connection, so they can terminate. So what happened with this? Data segment from the server to client, and acknowledgement from the server to client will happen. Okay, then connection can be closed. But here only half close cannot be used. Apart from this, there are different cases of the termination, and in the current termination cases, the connection reset can be happened. This connection reset, TCP at one end may deny a connection request, may abort an existing connection, or may terminate an idle connection. All these threes are done with the RST, that is reset flag. How these are going to be done? Let's take for the very first one, denying a connection. Suppose TCP on the one side has requested connection to the non-existence port. The TCP on the other side may send a segment with its RST, that is reset bit, to set the deny the connection. So if one is not ready, then it can be denied, and that can be denied with the reset connection, reset flag. Okay. Second, aborting a connection. One, the TCP may want to abort an existing connection due to abnormal situation. It can send the RST segment to close the connection. We also showed the example of this case in the next. Okay. Here, the abnormal situation happens that time the aborting connection can be happened. If someone is not ready, the field has not set, etc. Then terminating idle connection. That is the third case. Terminating idle connection. The TCP on one side may discover that the TCP on the other side has been idle from long time. So whatever we are going to discuss in the timers. So if the sender and receiver is available, and if the sender is, that is what the client is more idle from the longer time, so that time this is going to happen. It may send the RST segment to the end of the connection. This process is same as the aborting the connection. So these three cases are happened: denying connection, aborting connection, and termination of idle connections can be happen. So these are the terminations of the TCP connection. So what we have discussed in this particular lecture, the connection establishment, data transfer, and connection termination. As the TCP is what the connection oriented protocol, so we have to work on this. So gist of this side, guys, very first, client send the first segment, that is sync segment, which only sync flag is set. As a reply, server send the second segment, that is a sync plus acknowledgement. The two flag are going to be set, the acknowledgement and the sync is going to be set, control flag, and then client send the third segment with just for acknowledgement. So acknowledgement flag is going to be sent. So this is what the connection establishment. So while the connection establishment, client make a request with the provision of all the fields. As a reply, server reply to that particular request. Once the reply from the server is received by the client also responds to the server, and this is called as what the three-way handshaking. This is called as what the three-way handshaking. And after that, the data transfer can be done, and after that, termination to be done of the connection, because in this particular internet, whatever the path we are establishing, we are setting virtual path we are setting for our purpose, that need to be removed, because there are so many users are available, and that users are again waiting for the connection. And if we not terminate our connection, the others cannot get the times to send their data, to send their segments or whatever. So here it is duty to have this particular kind of scenario. I hope, guys, this is okay with you. After that, we are going to discuss about the flow control and the subsequent lectures. Okay, thank you.